Welcome to the deep dive. We're here to, well, do exactly that. Take a bunch of information and really pull out what matters for you.
hmm
Today, we're digging into Dr. Ed Ashby's Cut 2007 Update, Part 7. It's quite the deep dive itself, focused on broadhead performance.
It really is.
Our goal here is simple. Translate this, sometimes pretty technical research into practical stuff that makes you a better bow hunter, whether you're just starting out or been at it for years.
Absolutely. And this specific report gives us a great look at how broadheads hold up under, let's say, tough conditions.
Right.
Dr. Ashby tested these things on buffalo specifically, hitting ribs broadside and also those tricky angled scapula shots.
Yeah, those are the shots you hope you don't take, but sometimes.
Exactly. So we're trying to figure out, what makes one broadhead push through when things aren't perfect, while another one might just stop. What are those design features that actually count?
Okay, let's get into it. First up, the grizzly broadheads. The report mentions some early problems with the 160 grain version bending. What was going on there?
Yeah, it's pretty interesting how basic material science plays a role. The first batch of 160 grain grizzlies, they had a Rockwell hardness around R50.
Okay, Rockwell hardness. Remind us.
Right, think of it like a measure of how well the steel resists getting dented or permanently deformed. Lower number, generally softer steel.
Gotcha.
Now, the 190 grain grizzlies were harder, testing at R52 minimum. That difference, plus the fact the 160 is shorter, well, that means less leverage. Engineers call it lower mechanical advantage.
Less leverage to push through stuff.
Exactly. Less leverage to overcome resistance, making it more likely to bend on a hard impact. It also needs more direct force to get through bone because of that lower mechanical advantage.
So it's not just weight, but the steel's quality and the head's geometry working together, or not working together initially.
Precisely. So to sort this out, the maker sent a new batch of 160s, but these were hardened up to R52, R53. Then they ran the same tests, buffalo ribs, angled scapula hits.
And did hardening them up make a difference?
Oh, a huge difference. These harder 160 grain grizzlies, they were shot on 815.5 grain laminated birch shafts. Momentum was about 0.492 slug feet second.
Okay.
The average penetration on those broadside rib shots, it jumped to 14.31 inches. Pretty good.
Wow. Yeah, that's a big improvement.
And even on the scapula hits, which are really tough, they averaged 5.0 inches. Crucially, the report states these harder heads didn't bend, unlike the R50 versions.
Okay, so takeaway number one for bow hunters. If you're going after bigger animals or just want that extra assurance against bone hits, looking for broadheads with R52 hardness or higher seems like a solid plan.
Definitely a key factor.
Now, the report shifts gears a bit, looking at the Outback Supreme. This
Yeah.
is interesting, steel versus aluminum ferrules.
Yeah, this was a prototype Outback Supreme they tested, one with a steel ferrule. They compared it against earlier results from the same head design, but with an aluminum ferrule.
Okay.
This steel version had a single bevel blade, 0.073 inches thick, hardened to R51, and it had that Tanto-style tip, weighed 209 grains.
Pretty hefty. What was the arrow setup?
It was heavy, too. 880 grain carbon double shafts, 11.1% FOC, good stability there, and hitting with 0.529 slug feet second of momentum. A real thumper.
Okay, so how did that steel ferrule handle hitting bone?
On the broadside rib shots, it was frankly outstanding. Averaged 16.29 inches of penetration. Almost all of them went deep into the offside ribs of these big buffalo.
Into the offside ribs. That's serious penetration.
Yes, and even on those tough angled scapula shots, sometimes they'd hang up where the ferrule meets the blade, but critically, zero damage to the broadhead itself.
Huh. That sounds much better than the aluminum version you mentioned. What are the problems there?
Right, the earlier tests with the aluminum ferrule, even on smaller game, they showed this really wide penetration range, like 8 inches sometimes, 19 inches others. Very inconsistent.
Not what you want.
No. And worse, nearly 23% of those aluminum ferrules actually failed, bent, or broke. And when the ferrule failed, penetration just tanked. So the steel ferrule just provided way more consistent penetration and durability, enough that Ashby put it on his best broadheads for heavy game list.
So another key point. For really tough animals, that steel ferrule could be a real difference maker for reliability and getting the penetration you need. Okay, let's talk Magnus. The Magnus Me, the 160 grain Delta, what did the tests show?
Well, the Magnus I had already been tweaked. They gave it a Tanto tip because the older needle tip was prone to bending.
Right. The Tanto tip seems to be a recurring theme for strength.
It does. So they tested it with two setups. First, those lighter laminated birch shafts, 790 grains, 9.6% FOC, about 0.477 momentum.
Yeah.
The results weren't great. One broadside rib shot got only 6.375 inches, barely squeaked through the rib. Two other shots hit the shoulder area but missed the main bone. They only got about 8 inches and didn't penetrate the rib either.
Not exactly inspiring confidence there.
No, definitely not.
What about with the heavier arrows, the double shaft carbons?
Okay, heavier setup. Per 354 grains, 13.8% FOC, hitting harder at .577 momentum, performance improved. Average penetration on broadside ribs went up to 12.754 inches.
Better.
Yeah, one was a clean double lung, another stopped in the near lung, and the third just nicked the far lung. So the Magnus thing is strong. It didn't break.
Okay.
But the report notes its wide profile seems to really limit its bone penetration. And its mechanical advantage, that leverage factor, is apparently only a tiny bit better than the old Wenzel-Wisman design. Bottom line, it seems to struggle getting through that first rib.
Interesting. So strong, but maybe the width works against it in bone. Yeah. Okay, how about its sibling, the Magnus II, the 125 grain standard? Also got the Tanto tip, you said?
Yep, same Tanto tip upgrade. Tested on the same two arrow types. With the lighter birch arrow, 743 grains, lower FOC at 6.3%, momentum 0.475.
Okay.
One broadside rib shot did okay, 11.25 inches, single lung. But the second shot, the blade actually chipped near the tip after it went through the rib. Penetration dropped to 7.125 inches.
A chip. Is that bad? Sign of poor quality.
Well, the report speculates it might have been a localized issue. Maybe a bit of steel got overheated during manufacturing, making it brittle right there.
Ah, okay.
But Ashby actually notes that, generally speaking, chipping is often better than bending. A chipped edge usually takes away less penetration potential than a bent, deformed head.
Huh. Interesting perspective. So what happened with the Magnus II on the heavy carbon arrows?
Much better story there.
Yeah.
The 1017 grain arrows, 12.65% FOC, 0.542 momentum. All three broadside rib shots went clean through and reached the offside ribs.
Actually.
All three. Average penetration was 18.67 inches, really consistent too, between 18.5 and 19 inches.
Wow, okay. That's a significant difference from the lighter arrows and from the Magnus I. So the overall take on the Magnus II.
It performed well overall in these tests. Now, previous testing had shown it could occasionally bend a blade on really severe angled bone hits, but the conclusion seems to be, with that stronger Tanto tip, and if you avoid those, really bad angle on bone impacts, the Magnus II, much like his wiki, which people know well, can be a solid choice for big animals, provided you've got a good heavy arrow setup. Shot placement still matters, obviously.
Makes sense. Avoid the worst angles. Use enough arrow weight. Okay, Next on the list. The Ace Standard, 125 grains. Sounds like this one had a rough start in the tests.
Yeah, it did. These initial tests used the standard factory needle tip, not a modified one. First round used tapered hickory shafts, 775 grains, 9.1% FOC, 0.516 momentum.
And the results?
Not good. 4 shots, all broadside, just behind the shoulder, hitting only ribs. None of them penetrated the rib cage. Average penetration was just 5.5 inches.
Oof. Yeah, that's definitely not getting the job done on a buffalo.
Not even close.
So did they try it with the heavy carbon double shafts like the Magnus II?
They did. Same setup as the Magnus II, 119.5 grains, 12.7% FOC, 0.543 momentum.
Yeah.
So very similar impact energy. One shot actually broke the arrow shaft and bent the adapter, only got 4.5 inches, no rib penetration. The other 2 shots, where the arrow didn't fail, did penetrate. They got 14.875 and 15.25 inches. Modest double lung hits. Average for those two was 15.06 inches.
Okay, so definitely better with the heavy arrow, but still not quite the performance of the Magnus II on the exact same setup, right?
Exactly. And this is where Ashby draws a really fascinating comparison. He tested the Ace Standard right after the Magnus II. Same animal, same arrows, everything essentially identical.
And the specs are similar too?
Pretty similar in some ways. Both have that convex blade shape, though the Ace is maybe a bit more rounded. Different tips, obviously. Tanto versus needle here. Similar ferrule designs, triple layer tips of about the same thickness. The Ace blade is actually a touch longer, maybe a tiny bit more arrow weight. Impact force was basically identical.
So you'd kind of expect similar penetration?
You'd think so, wouldn't you? But the Magnus II penetrated, on average, 24% deeper than the Ace Standard.
24%? That's a lot.
It is. And even the worst Magnus Mechana shot still penetrated over 21% more than the best Ace Standard shot. Plus, remember, all the Magnus Desert shots reached the offside ribs. The Ace didn't. So the real difference might be even greater.
So why? What was the key difference?
The report points to something visible right on the broadheads. The Magnus II has a totally smooth blade face, where it transitions from the ferrule. The Ace Standard has these 5 little raised dumps or lugs right there.
Little ridges on the ferrule where it meets the blade.
Exactly. And the theory is, as that head pushes through tissue and especially scrapes against bone, those lugs create way more friction and resistance. Bone and tissue basically have to get forced over and around them.
Huh, like speed bumps for penetration?
Kinda, yeah. Ashby uses the analogy of running your finger over the smooth Magnus blade versus the bumpy Ace transition. You can feel the potential for drag.
Wow.
It really hammers home that tiny design features can have a massive impact, especially if your setup is maybe lower draw weight or you're hunting really big, thick-skinned, heavy-boned animals.
That's a critical insight. It's not just the big picture shape.
Right.
Okay, what about the heavier Ace, the 200 grain Super Express? Same lug issue.
Seems like it. The 200-grain Ace Super Express was tested with those hickory shafts again, 848 grains, 13% FOC, 0.519 momentum. Again, penetration was limited.
How limited?
2 broadside, behind-the-shoulder rib-only hits failed to get through the ribs, 6.5 and 7 inches. Another shot hit the shoulder, missed the heavy bone, but still stopped right at the near side rib after only 11 inches.
So even heavier still struggled with ribs.
Yeah. The report suggests its wider cutting diameter, combined with those same surface lugs, just created too much resistance to penetrate well, especially through bone.
So wider isn't always better if it costs you penetration. All right, last one on the list here. The Cheetah Broadhead. This one was a single bevel, right?
Yes, a right-hand single bevel. Tested with a heavy setup, again, 932-grain aluminum carbon double shafts, 10.4% FOC, 0.541 momentum, 6 shots total.
How did it do?
Well, 2 shots that hit the scapula directly only got 4.875 and 6.875 inches. Didn't make it through the bone.
Okay, scapula's tough. What about the other 4?
The other 4 were behind the shoulder, hitting ribs. All 4 did penetrate the near side rib, averaging 14.375 inches overall. But it was inconsistent.
Inconsistent.
2 shots were fantastic, punched right through the chest cavity over 19 inches, lodged in the far ribs. But the other 2 were pretty shallow, less than 10 inches, just modest single lung hits.
Big difference between 10 inches and 19 inches. Any idea why the inconsistency?
The report suggests it might be linked to the cheetah's ferrule design, which is an open ring style.
Open ring.
Yeah, not a solid tube. And across Ashby's testing, heads with that open ring design sometimes show this kind of variable performance when they hit bone. It's like the ring might catch or hang up differently depending on exactly how it impacts the bone structure.
Interesting. So that design might introduce some unpredictability on bone. Now, how did this single bevel cheetah compare to the double bevel version tested before?
This is maybe one of the most important findings in this section. The double bevel cheetah, tested back in 2004 on the same arrow setup.
Yeah.
It had a 50% failure rate, just penetrating the entrance rib on similar shots.
Yeah.
Half the time, it didn't even get into the chest cavity properly. Its average penetration was only 7.9 inches. Max was just over 12.
Wow, 50% failure on the first rib
Yeah.
compared to the single bevel getting through every time.
Exactly. The single bevel version here showed vastly better penetration when bone was hit. This leaves Ashby to state pretty strongly in the report
What's that?
that when hitting bone, single bevel broadheads seem to have a distinct penetration advantage over double bevel heads of similar design. And he notes this has been a consistent finding, 100% correlation across all his tests comparing the two.
That is a powerful conclusion, a real potential benefit for single bevels if you anticipate hitting bone.
It seems so. The report also quickly dismisses the idea that open rings might help by chipping bone away to reduce shaft drag. The data just doesn't support that. One interesting side note. The cheetah's factory needle tip held up. It was the only needle tip tested extensively in this series that didn't bend or break. So it's a sturdy head overall, though one furrow ring did crack eventually.
Okay, wow. We've covered a lot of ground, a lot of different broadheads and test results from this Ashby report. Let's try and boil it down. What are the absolute key takeaways for listeners from this deep dive?
Yeah, let's summarize. I think, first, broadhead hardness that Rockwell R52 or higher seems really crucial for preventing bending, especially on bone, like we saw with the grizzly.
Right, hardness matters.
Second, ferrule material. The Outback Supreme really showed how a steel ferrule can boost penetration consistency and durability compared to aluminum, particularly for tough game.
Steel ferrules for tough jobs, got it.
Third, those seemingly small design details. The Magnus versus Ace comparison with striking smooth transitions versus raised lugs can drastically impact drag and penetration. It's not just about the overall shape.
Yeah, the little things count. A lot, apparently.
And finally, the single bevel versus double bevel question. The cheetah tests added strong evidence that single bevels may offer a real penetration advantage when you hit bone.
So, hardness, ferrule material, surface details, and bevel type. Lots to think about.
Definitely.
It really drives home that picking a broadhead is way more complex than just blade count or cut diameter, doesn't it? These subtle features can make or break performance when things get real.
Absolutely. It's about how the whole system works together under stress.
So, as people listening are thinking about their setups for next season, what should they be weighing up based on all this?
I'd say, first, be realistic about the game you hunt and the likelihood of hitting bone. Then look into the specifics of what's the documented hardness. Is it a steel or aluminum ferrule? Look closely at the blade to ferrule transition. Are there potential drag points? And seriously consider that single bevel versus double bevel difference, especially if angled shots or bone impacts are a significant possibility for your type of hunting.
This report, Cut 2007 Update, Part 7, it's just packed with this kind of detail. An amazing resource if you really want to get into the weeds of your setup.
It is. And Ashby even mentions that Part 8, which we didn't cover today, summarizes all the factors found to enhance penetration. So there's always more to learn if you want to optimize further.
Always more to learn.
Which kind of like leads to the final thought, maybe something for you, the listener, to chew on.
Yeah.
How can really understanding these sometimes subtle differences in how broadheads are designed and built actually empower you? How can it help you make more confident shots, more ethical shots, and ultimately be more successful out there?
That's the core question, isn't it? Moving beyond just brand names or marketing and really understanding the physics and materials at play.
Exactly. Grounding your choices in research and how these things actually perform when it counts.